So in the general force system, we have already seen how to find out the resultant for the general force system. What are the steps to find out this resultant? Then how to use the Varignon's theorem to find out the perpendicular distance of that resultant with respect to any given point of the system, and how to find out the intersecting point of the resultant with respect to either x-axis or the y-axis from the given point. Okay. So in this session, we will solve some problems on the general force system. So this is one problem. So the problem statement is a beam is subjected to two forces 6 kilonewton and 4 kilonewton as shown. Determine the resultant of the system and locate the resultant with respect to point A. Okay, so this is the problem statement. So is the screen visible to you? The heavy load and generally it is used in the construction of the buildings. So the beam is subjected to two forces. One is 6 kilonewton and second is the 4 kilonewton as shown in figure. And we have to determine the resultant of these two forces, and we have to locate the resultant with respect to point A. So this is the given structure. So this is the simplified diagram. So this is the point A. Then this is the vertical force of 6 kilonewton. Suppose this point is point B. And this is the inclined force. It is of 4 kilonewton. And this is the line which is parallel to x-axis. So this angle given 30 degree for the 4 kilonewton force, it is with respect to the x-axis. Okay. Then some dimensions are given. So this is equal to 1.5 meter. This is also 1.5 meter. And this inclined distance is equal to 1.5 meter. Okay. And the angle of this part, it is 30 degree. So when you find out the resultant, first we have to find out the resultant. Okay. So the steps for the resultant calculation is, first we have to resolve the forces. So for the resolution, we have to only observe the forces which are inclined to x-axis or the y-axis. So if you observe this 6 kilonewton, it is exactly acting in the vertically downward. So it is on the y-axis. Okay. So there is no need to resolve the 6 kilonewton. But if you observe the 4 kilonewton, it is inclined by 30 degree with the x-axis. So we have to resolve that force along x-axis and along the y-axis. Okay. So let us resolve that force. So when we resolve the force, just observe the direction of this vector. So this is the direction. So consider this is the x component and this is the y component. So angle 30 degree, it is with respect to x axis. So x component, it will be adjacent component. Okay. And we use adjacent as a cos. So this value will be 4 cos 30 degree. And this value will be 4 sin 30 degree. Okay. So this is the resolution. Now next step is we have to take summation fx and summation fy. So summation fx means what? We have to add all x components. So first x component is 4 cos 30. It is acting in positive x direction. So it is plus 4 cos 30. There is no other component in the x direction because 6 kilonewton, it is completely acting in the y direction. Okay. So summation fx is only 4 cos 30. So you can get this value 4 cos 30. Then write down summation fy. So summation fy, consider the y direction forces. So first is 6 kilonewton acting in negative y direction. So this is minus 6. Second component is 4 sin 30. So it is minus 4 sin 30. Only two forces in the y direction. Okay. So find out this addition. Minus 6 minus 4 sin 30. So the value of summation fx, that is a 4 cos 30, it is equal to 3.46. This is kilonewton. And summation fy, which is minus 6 minus 4 sin 30. So this value, it is minus 8. Okay. So this 3.46 kilonewton, as the answer is positive. So its direction, it is towards the positive x direction. And minus 8 kilonewton, this is the summation fy. That means its direction is 8 kilonewton. This is the magnitude. Okay. And it is acting in the negative y direction. So these directions are important to decide what is the quadrant of the resultant. Because the summation fx is nothing but the x component of resultant and summation fy is nothing but the y component of resultant. So we can locate the resultant in the last quadrant, that is the fourth quadrant. So this is the direction of summation fx. This is the summation fy in the negative y direction. So we can say resultant, it is acting in the fourth quadrant. So this is the resultant R. And this angle with respect to x-axis, it is taken as a theta. Okay. So theta we can find out by using formula tan inverse summation fy divided by summation fx. So when you use this formula tan inverse summation fy by summation fx, Just put the positive values only. So it is tan inverse 8 divided by 3.46. So your answer is, it is 66.61 degree. So your resultant total representation R is equal to summation fx square plus summation fy square. So this is equal to, it is 3.46 square plus 8 square. So that is equal to 75, 8.71, and this is kilonewton. Okay, and its direction, it is in the fourth quadrant, such that theta is equal to 66.61 degree. Okay, now this is the first part of the question. We have to determine the resultant. So when the question is determine the resultant, that means we have to find out the R value, that is the magnitude, and we have to find out the angle theta with respect to x-axis or y-axis. Now second part in the question is locate the resultant with respect to point A. So what is meaning of locate the resultant? We have to find out the point from point A along the x-axis where resultant will intersect the x-axis. Okay, so let us take this point. So this is the point of intersection of the resultant R. So we have to find out this x distance. Okay, so up to this step, is it clear to you how to find out the resultant? Okay, so now we will try to find out the distance of the resultant with respect to point A. So this is the force system, or you can say it is a system of forces. Now we have to draw the resultant system. So for the resultant system, so this is the original beam. This is point A, this is point B. We know the direction of the resultant. R is acting at angle theta with respect to positive x-axis, and it is in the fourth quadrant. So just draw the resultant, which is parallel to this line. So this is the resultant R. This is the axis, and this is the angle theta with respect to x-axis. Okay. So right now this resultant R, it is intersecting the horizontal line at this point. Okay. So let us take this point as a point M. So we have to find out the AM distance. So this AM distance is taken as a x. But we cannot find out directly the x distance by using Varignan's theorem. So for the Varignan's theorem, we have to take the perpendicular distance. So let us draw a perpendicular from point A on the resultant line. So this distance D is the perpendicular distance of the resultant with respect to point A. So this system is called as a resultant system. So now we can use the Varignan's theorem. So what is Varignan's theorem? Summation of moment by all the forces about any point is equal to the moment by the resultant about the same point. So to find out the LHS, just refer the system of forces, and to find out the RHS, refer the resultant system. Okay, so first try to find out the left hand side. So refer this system of forces. So by referring this system, that is system of forces, we will find out summation of moment by all the forces about A. So consider the first force, that is 6 kilonewton. So what is perpendicular distance of 6 kilonewton with respect to point A? It is 1.5. So we will write the moment 6 into 1.5, and this moment, it is in the clockwise direction, because 6 kilonewton, when it is acting on this beam, it will try to rotate the system in this direction, that is a clockwise. So it is minus 6 into 1.5. Now second moment, now forget about this 4 kilonewton, because we have resolved this 4 kilonewton into y component and x component. So we have to take the moment by individual component, 4 sine 30 and 4 cos 30. So first consider this 4 sine 30. So perpendicular distance of this 4 sine 30 is not directly available. Okay, so we have to find out that perpendicular distance. So observe this separate figure. So this is A point and this is the point B. 4 sine 30 is acting at this point like this. This is 4 sine 30. Okay, and this angle, it is 30 degree. So this distance, it is equal to 1.5, and this total distance, it is equal to 3 meter. So to find out the perpendicular distance, so this total distance, it is nothing but the perpendicular distance. So this is equal to 3 plus this distance. So this is equal to 1.5 cos 30. So this is 1.5 cos 30. Okay. So total perpendicular distance is 3 plus 1.5 cos 30. So this moment will be, force is 4 sine 30 into perpendicular distance, it is 3 plus 1.5 cos 30. And this complete moment, it is again in the clockwise direction, so it is negative. And the last moment, because of 4 cos 30, so force is 4 cos 30. And perpendicular distance, so this is the 4 cos 30 and this is the line of action. So this distance from point A, it will be perpendicular distance. So we can find out this distance by using this 1.5. So this is 1.5. This angle is 30 degree. Okay. So this distance, it will be 1.5 sine 30, because this is the opposite side. Okay. So perpendicular distance for 4 cos 30, it is 1.5 sine 30, and this moment, this complete value, again this moment is clockwise because it will try to rotate the system in this direction. So it is minus. Okay. So this total value is minus 20.2 kilonewton meter. So this is the left hand side, summation of moment by all the forces about the point A. Now just observe the right hand side, moment by resultant about the point A. So for the right hand side, we have to refer this resultant system. So from the resultant system, we have the perpendicular distance D and we know the value of resultant. Okay. So moment by resultant about the point A is equal to R into D, and again this moment is clockwise. So it is minus R into D, that is equal to minus R is 8.71 into distance is D. Now compare these two values. So we can write minus 20.2 is equal to minus 8.71 into D. So we will get D is equal to 20.2 divided by 8.71. So that is equal to 2.31 and unit is meter. Okay. So now we have got the perpendicular distance from point A. Now we have to find out the distance along the x-axis where this resultant will intersect the horizontal axis passing through the point A. So to find out the x distance, we know this angle theta. That means we have this angle. So it is the same angle theta. This complete triangle is a right angle triangle and this is the diagonal for that right angle triangle. Okay. So this is theta. This is 90 degree. This is D distance. This is point A and this is the x. So we can use, as the opposite side is known and diagonal is to be determined. So we can use the sine theta in this triangle. So sine theta, it is equal to opposite side, that is a D, divided by the diagonal, that is x. So x is equal to D divided by sine theta. So D distance is 2.31 and theta is sine 66.61. So we will get the answer. It is 2.52 meter. So this is your final answer. That means this resultant will cut the x-axis at distance 2.52 meter with respect to point A. So we can represent that resultant on the original diagram. So this is the resultant and x distance, it is equal to 2.52 meter. So I hope this problem is clear to you. So the next point is resultant force and couple system. So you know the meaning of the resultant. Resultant is nothing but the single force which will give the same effect of the original system. That is called as a net effect or the equivalent force. So what is meaning of couple? When two parallel forces are acting on a system exactly in the opposite direction to each other, and if they are separated by perpendicular distance d, then they will try to rotate the system about a point. So this system or effect is called a couple. So you can consider we have one rigid body and there are two forces, that is F and another force is F. That is both the forces are having equal magnitude. So two parallel forces with same magnitude. They are separated by perpendicular distance d. So these two forces, they will form one couple on this object. Okay. So this couple value, sometimes it is represented as a C, or we can represent this as a M, which is equal to the force and perpendicular distance d between the two forces. Okay. So this value is F into d. So unit will be Newton meter. So this is called as a couple. So what is the effect of this couple? So we can draw equivalent diagram. So it will try to rotate the system like this. Right now it is clockwise because force direction F in this direction, that is right side, and for the second force it is towards the left side. So they will try to rotate the system in the clockwise direction. So this value is M is equal to F into D. So this is called as a couple. Okay. So the example for the couple, so we can take the example of the automobile steering wheel. So this is the automobile steering wheel. Okay. Now when we want to take the right turn or the left turn, we rotate this wheel, that is the steering wheel, by applying some forces. Okay. So suppose we want to take the right turn, then we have to apply the force at this point and second force at this point. Okay. So we apply these forces, this is F and F, okay, by using our hand. So we can rotate it on the right side or in the left side. Okay. So right now for this condition, when F is acting in the upward direction and F is acting in the downward direction, they will form one couple. Okay. And this couple will rotate this wheel in the clockwise direction. Okay. So how to find out the magnitude of the couple acting on this wheel? For that, we have to measure this perpendicular distance. Okay. So this perpendicular distance, it will be the diameter of that wheel. Okay. So moment which is acting or couple on this wheel, it is equal to force into perpendicular distance d. So its unit will be Newton meter. Okay. So I hope this concept is clear. What is the meaning of a couple? So we can represent this complete effect So instead of forces, you can show only couple, and we can give the magnitude M is equal to F into perpendicular distance T. Problems on the force and couple system. So please check whether it is visible to you, this problem. Is it visible? So the question is, a lever is subjected to different forces and a couple at point A replace this system by a resultant force and couple system. A lever is subjected to different forces and a couple is acting at point A. Replace this system by a resultant force and couple system. That means first we have to find out the resultant. That means its magnitude and the angle theta. Then we have to convert that system into resultant force and couple system. Okay, at point O. That means the pivot point or the hinge point. So this is the pivot point. So to find out the resultant, we have to resolve the forces, then take summation fx, summation fy. Okay, and then we have to find out the result. So I will draw the simplified diagram for the given system. So this is the point A. This point is O. This is 400 Newton. Let us take this point. So this is point B. This is C. This is horizontal direction. And this is 320 Newton force. It is acting at 60 degree. Then this angle for this lever with respect to x-axis, it is 30 degree. And these are two forces. One is 100 Newton and second is 100 Newton. Okay. So first step, we have to find out the resultant, its angle theta. So you can resolve these forces. So we have to only resolve one force, that is the 320 Newton. Okay. So this is the point where 320 is acting. So this is the x component. So this is 320 cos 60, and this is the y component. So this is 320 sin 60. Okay. So take summation fx, which is equal to, first is 100 Newton acting in the negative x. So this is minus 100. Second is 100 Newton. So this is plus 100. So net effect will be 0. Then next is 320 cos 60. So plus 320 cos 60. So summation fx, this value will be, it is 160 Newton, and it is positive. So it is positive x direction. Similarly, find out summation fy. So for summation fy, we have minus 400, then minus 320 sin 60. So this is equal to minus 677.13 Newton. That is 677.13 Newton in the downward direction. Okay. So this is summation fx and summation fy. So we can decide the quadrant. So quadrant will be fourth quadrant. So this is the resultant, and this angle is theta. So we can find out theta tan inverse summation fy divided by summation fx. So this value is, tan inverse summation fy is 677 and summation fx is 160 Newton. So angle is 76 degree, 76.71 degree. So this is the first part of the question. We have to find out the resultant force. Now when we want to replace that system by a resultant force and couple system at point O, that means first we have to find out what is the distance of that resultant with respect to point O. So we'll try to find out that distance by using Varignan's theorem. So now we have got the value of R. We can use the formula summation fx square plus summation fy square. So that is equal to, it is 695.77 Newton, and theta is equal to 76.71 degree. So this is the direction. Now second step is we have to locate the R with respect to point. That means we have to find the perpendicular distance from O. So for that we can use the Varignan's theorem. So for the Varigna's theorem, we have to draw the resultant system. So for the resultant system, so this is the beam or the lever. Okay, so this is A point, this is point O, and this is the C point. So we will assume the resultant is acting like this, which is in the fourth quadrant. This angle is theta, that is 76.71, and resultant is acting on the right side of the point O. We don't know whether it is acting on right side or it is acting on the left side. So just assume it is acting on the right side and assume this perpendicular distance as a d. So we can find out perpendicular distance d by using Varignan's theorem. So for the Varignan's theorem, we have to refer this diagram and the first diagram, that is the system of forces and the resultant system. So this is the equation for Varignan's theorem, summation of moment by all the forces about point O right now, and moment by the resultant about the same point O. So for left hand side, refer this diagram. Okay. So in this diagram, summation of moment by all the forces about point O is equal to the, now start from the x component 320 cos 60. So what is the perpendicular distance with respect to point O? So this is the line of action and this is the perpendicular distance. Okay. So it is not directly given. So for that, we have to refer the original diagram. So you can see here, this is 150, this is 150. So this is 0.15 meter. And this is also 0.15 meter. So total will be 0.3 meter. This total distance OC. So we can find out this distance. So this is 0.15. This is 0.15. So it is 0.3. So this is the opposite side. This angle is 30. So this is equal to 0.3 sine 30. So this is the perpendicular distance for this component 320 cos 60. So we will write the summation of moment. Force is 320 cos 60 into perpendicular distance is 0.3 sine 30. So this is the first moment and this moment is clockwise. So this is minus. Second moment is because of 320 sine 60. So for this force, this is the line of action. So this will be the perpendicular distance and this is equal to, this is the diagonal 0.3. So this is equal to 0.3 cos 30. So second moment will be 320 sine 60 into 0.3 cos 30. And this moment is again clockwise. So this is minus. The next force is 400 Newton. So for the 400 Newton, it is acting at this point. So this small distance, it is the perpendicular distance, which is the highlighted distance. Okay. So this is equal to, this is 0.15. So we have to find out this distance. So 0.15 is the diagonal, 30 is the adjacent angle. So we can find out this side as a 0.50 cos 30. Okay. So we can write here minus, because moment is again clockwise, 400 into 0.50 cos 30. This is the third moment. And there is one individual couple in the system because of 100 Newton and this 100 Newton. Okay. So this perpendicular distance This is 0.4 meter. So moment will be, or couple will be 100 into perpendicular distance between the two forces, that is 0.4 meter, and this moment is anti-clockwise. You can observe here, this is the direction for the forces, so it will try to rotate the system in this direction. So this is plus. So this is total left hand side. So you can find out this total answer. So this total answer, that is summation of moment, this is equal to minus 107.96. This is Newton meter. Okay, now refer the resultant system. The moment by the resultant about the same point O is equal to, so this is the resultant R, this is the perpendicular distance, so this is R into D, and moment is clockwise, so minus R value is 695.77 into distance D is unknown, which is to be determined. So now compare these two values, summation of moment and moment by the resultant. So it is minus 107.96 is equal to minus 695.77 into D. So D is equal to this 107.96 divided by 695.77. So which is equal to, this is 0.155 meter. Okay. So this is the perpendicular distance. So now we have to replace that system by a force and couple system. So what is force and couple system? So this is the lever. So originally different forces and couple were acting on this lever. Then we have converted that system into a single force, that is called as a resultant force. So this is that resultant R, which is equal to 695.77 Newton. Then this is the perpendicular distance D from that result with respect to point O, which is the given point. Now we have to replace that complete resultant about the point O. That means we have to shift the resultant at point O and we have to draw the equivalent effect. So its equivalent diagram will be, just shift this resultant as it is at point O and take the moment by this resultant about the point O. Okay. So first we will write down the moment by the resultant about the point O, which is equal to, it is 695.77 into distance is 0.155. So this moment will be same. This is the 107.96. So it is 107.96 and this is clockwise. Okay. So your equivalent diagram, that is called as a force and couple diagram. So this is the lever. So this is point A, this is O, and this is the B. Now just shift this resultant at the point O. So this is the resultant R. Its direction will be same, that is a theta. And additionally show one couple which is equal to the 107.96. So here m is equal to 107.96. This is Newton meter. So this is called as a resultant force and couple system about the point O. So this will have the same effect like this system. Okay. So I hope this point is clear. How to convert a given system, that is a given complex system, into a equivalent force and couple system about the given point. So if you have any doubt, you can ask.